I'd like to welcome everyone back to the final presentation of the first day of SEMA from the collision repair and refinish stage. And we're going to talk about the ADAS blind spot and why ADAS calibrations fail. And why don't you guys introduce yourselves and we'll get started.
Yeah, thank you. Hey, I'm Stu. I work with Altel. I lead the ADAS division. And here today with Eric, who's my director of sales.
Good afternoon. Yes, Eric Sponholtz here with Autel, Director of Sales for the Autel ADAS team.
Appreciate it very much. So why don't we just jump right into what are we really going to be talking about today? Okay. So we're going to really walk through what are really causing the calibration failures. Our discovery and approach methods that we use to really uncover this. This isn't really how we feel about it. It's actually data that we're utilizing, each and every day. Our solutions, and then how we really are solving these problems. Why don't we just jump right into really our data? And that's really, this is a behind the scenes look of the calibrations that are being performed today with Autel tooling. So each month, around 250,000 on average, successful calibration events are happening with Autel tools, and we get around 2,400 tech support calls. Out of those 2,400 tech support calls, really it's the physical angle checks, it's the sensor angles, the unlevel floor, it's all the surroundings, in these shops. I hate to say it, a lot of technician errors along the way. That is really the main culprit here. We find a lot of, when it's software, it isn't necessarily that it doesn't communicate. It may be they're not looking in the right spot in the software, or it needs an update, or there's a variety of reasons around the coverage piece, but it's a pretty small percentage of really our calls. And then as we look at this, there's a manual setup procedures, and then we've really pushed in the last few years around optical setups. And what we see in our tech support calls is we see a huge reduction in these calls with systems that are using optical systems. So based on really a lot of technician feedback and what we see, we're enhancing the technician workflow. We're kind of putting safeguards in the processes so they can't move forward unless it's really being in the right spot. And what's happening is we're seeing a lot higher success rates. We're seeing better documentation, and we're seeing cars really repaired correctly.
I think that's something that, if the vehicle structure's not right, nothing's right. And that gets magnified with ADAS, and we've really seen that over the last few years. So I'm not really surprised that, you're finding that the physical issues is kind of the number one, because everyone thinks that an ADAS system, it's so complicated and it's electronic, and you start looking at all the modules, and a lot of times there's not a lot in a module itself. It's just little switches inside of there basically, and if it doesn't get the right current and things like that, that's when things go bad, but they're pretty reliable. But the physical, it's damaged, the mounting location damaged, that makes a lot of sense that it's easy to overlook because it doesn't take much to have that physical damage not show up visually, but when you start measuring things, you find it very quickly.
Yeah, and we'll show some of the slides here later, but this physical angle check procedures, they're in service information. They're just not in the diagnostic workflow like they should be. And so we've incorporated that. We've incorporated a lot of tools to really help, again, technician success along the way.
And that really comes down to the OEMs, when they write service procedures, are really dialed into you're diagnosing a problem with the system, not it's been in a collision and now you're repairing something. So they don't think that needs to be in there, but when we're doing our work, we have a lot of other pieces that we have to pay attention to, and so you have to know where to find that information to even find that angle.
Yeah, for sure.
We've got a lot of good data. The numbers show here because we've been doing it for a long time. Our first frame launched in 2018. So we're a diagnostic company. We're an ADAS company, and these numbers support that. And we're going to show you in a little bit. But optical systems have a slew of advantages that are going to really ensure success for everyone involved.
Yeah, so this first procedure here, this is actually on the diagnostic workflow in an Autel tool today. We actually did some demonstrations earlier at the SEMA showcase, and this procedure should be happening really in a collision before any calibration work almost every time. Some of our challenges are from the OEM perspective. On the collision side, these specs maybe not be given, but it's over on maybe another side or in service. And some of this could just be OEMs need to talk within themselves. Not saying that the specs don't exist, it's they may be in a different spot, and so it's hard to find these specs. But I feel like we've done a pretty good job pulling this together. We want tools that are going to report into not only our scan tool, but our workflow, so that it's validating the step and the repair along this journey.
And that's a common problem we have throughout collision repair is the information is in 100 different spots. We have to know where to look. And, some procedures have links to other procedures, others do not. And so it's really a mixed bag of where you find that information. And that's probably one of our biggest challenges overall. And then throw ADAS and calibration, it just magnifies it tenfold.
Hunting and pecking through pages and pages of service and repair information. And to your point, where does the path take you next, right?
Yep. This is just a scenario that what we see a lot of times where this picture just shows in order to make this particular calibration pass, you have to be outside of the spec. That's not a good way to do this, but it also does tell you, hey, if you're trying to calibrate this vehicle and you're having to be out of spec for a radar, you know that those physical angles are out. It has to be. Otherwise, you would be hitting that OEM spec each and every time. So if you've done all your preconditioning and you know the tires are right, you know everything is correct, but you have to raise that radar stand past the OEM spec to get it to pass, you better be taking that bumper off, and you better be, just going through the proper procedure. So that's really what this scenario is just, outlining. And this is really just, the scenario. Hey, if we had Bluetooth-enabled tools, this workflow, that wouldn't really happen. So Eric, why don't you talk more about the unlevel floor piece?
Yeah, let's talk about floors. Ideally, we all know what perfect looks like. The reality is that perfect is kind of hard to come by, especially when you're talking collision repair shops where we're sloping to drains, we're maybe in some older buildings, maybe there's a lot of reasons. And so the ability for a system to be able to compensate for that unlevel floor, we want people to do it right, we want people to do it correctly, but we want to give accessibility to shops that don't have the perfect floor. And so we can do that optically to pitch to a drain or floor by rolling the car. We've got a process built into our workflow that can compensate for that and allow that shop that has the space but maybe not the perfect floor to achieve that successful calibration.
I know when we set up our ADAS lab, when we first started looking at ADAS calibrations, to get a contractor to come in and say, this floor is level within so many millimeters, and they're kind of looking at you like, what do you mean you need a cement floor this level? And they had to really kind of go back and think about how to achieve that because it's just not something you normally do in cement work.
Right. Yeah, that's huge expense to that too. Not saying that you shouldn't attempt to do it. It's just in most cases that it's not advantageous to do it. So a little bit about optical positioning. Really, this is really a journey. In most cases, our cameras are able to not only 360 the vehicle, but we're also able to see the frame angle, and then we're able to position these targets in such a way that we're able to hit that OEM spec each and every time. If it doesn't hit those specs, we actually gray out the number, and we don't allow the technician to move forward until it is actually in the proper spec. So one of the main differences between the main a manual method versus optical is really just that, forcing the technician to hit the spot before we move forward.
And we're proud at Autel to offer 3 distinct solutions that have cameras that will help us with those placement, right? And again, whether it's alignment pre-check or full alignment capabilities, we can also incorporate all that into one piece of equipment, into one workflow, maximizing shop space and efficiency.
Another new technology for us is lighting can be a concern. How the light is in a shop at 9 a.m. versus 3 p.m. There can be a lot of variation, as everybody knows. Being able to control that is essential for success. Our digital target boards that we do use have a sunlight sensor built into them, so we're able to monitor the brightness and change the brightness of that target, whatever is required for a successful calibration. So I've actually tested this in my own shop hundreds of times, and this is a very, very good process that has been built into these target boards.
Yeah, and that's one challenge that I think a lot of people have been facing over the last 6 or 7 years, where we really started to get into a lot of ADAS calibrations. And it's one shop is they got a whole bank of windows and it's sunny out and beautiful, and then the next shop it's got little tiny windows and there's a dungeon and they have nowhere near the lighting. And even when we were setting up the ADAS lab again, to get the lighting right, having it where you could adjust it for dimmable and get those better calibrations, because sometimes it's too bright, another vehicle comes in there, it might be too dim, and it was a kind of a big challenge to figure out what the right mix was for all of that.
Yeah, I really would stress, be nice if every OEM could provide lighting spec. I think that would really help, the industry in general. If there was a way to actually test for that, we have a method here that does work, but for everybody that doesn't have a digital target board, what should we be trying to strive for? Why don't you jump into this one too, Eric, on integrated alignment checks and some of this?
Sure. One of the things that I think we start talking about doing repairs and getting into cars and calibrating ADAS is, did we ensure the vehicle was going down the road in the center of the lane and the thrust angle was correct? Because these systems and sensors that live in these fixed brackets on cars don't know if the car is going in the right direction in the middle of the lane. So integrating alignment pre-checks, and then, okay, if thrust is bad, okay, now step 2 is let's go to an alignment, right? Thrust is good, okay, I can proceed. Green is good, red is bad, of course, but in this scenario, we were looking at that system or sensor doesn't know that we're doglegging down the road. And so having that alignment workflow built into the shop's solution, I think, is really important, that we capture that information, that we're able to quickly understand what thrust is, and if we need to make adjustments as a result of it.
Yeah, and I think from a collision standpoint, the conversation shouldn't be around who's paying for that. Is it out or not? Worry about that contract with the end user. If you have to have that corrected before moving forward, it's just one of those deals.
Well, and that's one thing we have been teaching and preaching for years, that just because the alignment is green, if the structure's off, you can make the numbers come within spec, but it's going to eat tires, and people wonder why. Well, if the structure's never been straightened, you can have green alignment specs because it technically meets it, but all of your SAI and everything else is screwed up, and that's just detrimental for regular vehicles, let alone anything with ADAS parts on it. Now all of a sudden it's pointing off in a direction it shouldn't be, and there's just a myriad of issues. I mean, horror stories of vehicles going down the road and all of a sudden it slams on the brake because there's something in the ditch, and they get rear-ended, and it's all over the place on that kind of stuff.
So one of the things that we talk about quite a little bit is, what's the risk of printing your target boards today? Are you scaling them correctly? We know there are some OEMs that provide this. I think for us, we don't want to take that risk. We want to ensure manufacturing qualities. We want to ensure that the target is not only fit, form, function exactly the same as an OEM. The black has to meet a certain pigment. It has to, it can't be too reflective or not enough reflectivity. So when we look at this, the stands matter, the targets matter. We hold our targets to OEM specs, and we really want to make sure a quality product goes out all the time. So
Yeah, what you see in this picture is just a lot of variance and a lot of chances for variance. And is that good when we're trying to achieve repeatable results? No.
Well, and when you start looking at all the different targets out there, and like you said, okay, printing them off. How many people look at that fine print? They just print it, put it up there, and say, "Oh, well, they said I could print it, so it's fine." And if you don't look at it, it's believe printers can really vary amazingly more than you would think.
Yeah.
And it's just one of those things that there are so many terrible examples out in the industry, social media. You see it, and you just shake your head and go, "What are we doing?"
Yeah, we agree.
100%.
So, Eric, you want to talk more about the advantages of optical versus manual?
Yeah, optical does a number of things. It's a repeatable method. It's a faster setup time. It's a more accurate setup process, and it's something that we can document that really doesn't have any holes in the report. Right? The report doesn't lie. An optical system is going to get us to the right spot, or we can't go forward in our workflow. Versus a manual method, if someone did an ADAS calibration for you and showed you a report with a tape measure, was it done right? Who knows, right? But an optical system, those are some of the main advantages: repeatability, ensuring success, and getting to the right spot every time.
And I think that's something that the OEMs, they face a really big challenge because they're a worldwide company and they have to have a solution that works worldwide. And I know when ADAS first became a kind of a hot topic in the industry, it was one of those things that I said, I can't wait till companies can get a hold of this and get something better than a plumb bob and string. And, you look around and, solutions like this are a great improvement. And it's great to see some of the OEMs kind of getting on board with that and allowing some different strategies in the plumb bobs and string lines.
Yeah. I think if we could all agree that as long as we're hitting the spec, how we get there, we got to start using some technology to help our technicians. We need to be able to attract more talent into this industry anyway. And I think with technology we can do that. So I like your take on the would you allow somebody to use a tape measure? Well, same goes with the alignment. If you took your car to a shop and you needed the wheel alignment done, and they pull out a tape measure to set toe in and whatever else, would you feel real good about that? Would you even want to pay for it? So I think that's the same as we start looking at ADAS calibrations. We get to the point where this is affecting all the safety systems. We want to make sure it's right. Let's figure out a better way. So. I think with this, we see this a lot, unfortunately. We take a lot of tech support calls. The very first thing that we ask is, what's your setup look like? Most of these pictures that we get, they come from an Autel tool. They may be using our tool. They may be using somebody else's frame, somebody else's target, but the setup, and we want to see what's going on. Well, if we see palm trees in the background and it's outside, we're going to say, we can't help you. And that's what we say to people that call in for tech support. You need to have a controlled environment. Get this inside a shop. Let's figure out how to do this the right way. Because these are two polar opposites here. You got one of these pictures here on one side where they're so invested in not only their facility but their training. You can tell they got a clean place. Everything's got a spot. They're really invested in doing this the right way. We want, not saying every shop's going to be like that, but we want that commitment and doing shortcuts like the picture on the right. That's really, we're not going to help you. I'm just going to say it right now. We're not going to help you work through that problem.
It's the coaching on, okay, you need to do better. You need to get this to a better spot, because otherwise there's no way we can actually make this work.
Yeah. So Eric, let's talk about this Rivian approval. What's that mean for Altel, and what's it kind of really mean for the industry, and how we look at the Rivian OEM approval from our perspective?
Yeah, so I think what we were so impressed with Rivian is that they understood. We talk about using technology to calibrate technology, and so they were looking for another solution, a better way, and we are our IA700 and IA900 are approved as placement devices for the Rivian Certified Collision Network, which is growing, and it was a really fun experience to go through that process of hitting that mark, and then their attention to detail on how many times can you hit that mark and how accurate can you be was really important to them, and we applaud them for that, and it just shows we're going to use all of our placement methods like we talked about, get the target, put it in the right spot, and then as the best of both worlds, use a factory tool when required, like Rivian does, to perform that calibration. So our method plus their targeting or triggering the calibration leads to a success. So it's a pleasure to work with, and we're hoping more to follow.
I think for us, here's some of the key takeaways, though. We know the physical piece of ADAS is super crucial. Facts matter. I think our tech support, we're not trying to be the know-it-alls here. It was just when we see the problems, we're trying to help these customers each and every day. Following the steps and procedures, the physical angles are such a big problem. I think anybody that's in this ADAS space has to start considering, what type of technology you're going to use to help your technicians through this process. What tools are you really using? What can we do to level up the whole industry? We got these technicians. We got to help them be successful. We got to help them, finish it the right way and complete it. These vehicles go back safe, each and every time. So I think using our technology can help all shops. And then with the training that goes along with that, our academy is really taken off. We want to make sure that each tech gets trained properly. Even the service writer up in the maintenance shop. I mean, I know that's not collision, but this is happening even in maintenance shops today. We need to help everybody that we can.
All right. Well, it looks like we're out of time, but great presentation, and thank you guys for coming down and taking time out of SEMA to present, and thank you again.
Thanks for having us.
Thank you.